Hello everyone, welcome to my YouTube channel Target 100 in Mathematics by Shivesh Kumar Singh. And today we are going to practice some questions of the chapter Matrix. Okay, see some questions, no doubt it will be very lengthy. So I'll try to explain the questions. Maybe I'll not give you the complete solution. So if you have any doubt, you can write in the comments so that I can give you the complete solution. Okay, I will try my level best to explain the questions. Now you see, if and these questions I have taken from your NCRT exemplar or Adi Sharma book. Okay, so just try to understand these questions. If a square is equal to I means here identity matrix, then find the value of this expression. Now one thing here is the confusion among the students, that they say, can we use the identity of a minus b whole cube or a plus b whole cube or a cube plus b cube? Yes, you can. Why you can use here? Not in general for the matrix. Okay, if I say a and b are the matrix, then a plus b whole square, it will be a square plus 2ab plus b square. You will say, yes, where is the problem? Like we can use the identity of a plus b whole square and you will get this thing. Yes, but in the case of matrix, it will be wrong. Why? Because in matrix, you have studied that ab is not necessarily equal to ba unless it is given. If it is written in the question that a and b commute, then you can write ab is equal to ba. Otherwise, you cannot write. Okay. So, but here identity matrix is given. So, identity matrix has the property that ai is equal to ia and it will be equal to a. So, because of this line, we can use this identity here, a minus b cube or a plus b cube, whatever you want. Okay. So, let's continue the question. Question is this one. So, a minus I cube plus a plus I cube minus 7a. So it will be equal to what? A minus b whole cube. I am sure you know the identity. Just pause the video and revise it yourself and think, do you know this identity or not? So it is a cube minus 3a square b plus 3ab square plus minus b cube. Okay, like this you can write the identity here so that you can revise it properly. Okay, so it will be a cube minus 3a square I plus 3ia square minus I cube plus, for a plus b whole cube, identity will be a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus I cube. Okay, so here it will be a cube plus 3a square I plus 3ia. Why I am writing this? 3ai square plus 3ai square plus I cube minus 7a. Okay. Now, this positive and negative cancelled out, positive and negative cancelled out. Now, a cube you can write a square times a and it is 2 times, so 2a cube plus 3ai square. I square means I, because identity multiplied by identity matrix will be identity. So 6ai minus 7a. Okay. Now in the question they have written a square is I. So here it will be I. So 2I times a plus 6a times I means a minus 7a. So IA again, it will be 2a plus 6a minus 7a equal 6 plus 2, 8a minus 7a and equal to a. So hope this answer is correct with the correct calculation, because in between I got some call and then I think this video was not in the fluence. So maybe check the calculation. Okay, hopefully this answer is correct. Now next question can be, if fx is equal to this matrix, show that fx times fy equal to f of x plus y. So fx is given to us. What will be fy? Fy will be equal to, or I'll do one thing. I'll take it as left hand side. Okay, left hand side of this. So this is fx times fy. Write the value of fx here. Why I am writing like this? Because multiplication will be easier then. So this is cos x minus sin x 0, sin x cos x 0, and then 0, 0, 1 times, where it is going, times fy. So fy means just write y in place of x everywhere. So it will be cos y minus sin y 0, sin y cos y 0, and 0, 0, 1. Okay. Now just multiply them. And what was the procedure for multiplication? Take first row from here and first column from here and multiply the corresponding elements and add them. So this is cos x cos y minus sin x sin y plus 0, then first row second column, same procedure, minus cos x sin y minus sin x cos y plus 0, and then first row third column, so it will be 0 plus 0 plus 0. Okay. Same you will continue for all rows, and I am doing it little quickly. Okay. So second row and first column, it will be sin x cos y plus cos x sin y plus 0. Then second row second column, it will be minus sin x sin y plus cos x cos y plus 0, and third will be 0 plus 0 plus 0. Okay. And the last one, 0 times 0, 0 plus 0, and if you will multiply them, you will get the same thing here. Now, you can see, this is an identity. Identity of what? Cos x plus y. It is cos of x plus y. Here you will take minus sign common first, and then minus, after taking minus sign common, you will get cos x sin y plus sin x cos y. So this is the identity of minus sine of x plus y, and it will be 0. Then again down is also the identity. So this is sin x plus y. Second will be cos x cos y minus sin x sin y. So this is the identity of cos x plus y. It will be 0. Third row is 0, 0, 1. Okay. And now you can see, this is like the same function what was given in the question, this one. But in place of x, it is written x plus y. So its answer will be f of x plus y. Okay. Like this you can see this question. Next question can be, this very important question of NCERT, I guess. This is, if a is equal to given, then show that I plus a is equal to I minus a times this matrix. So I plus a is very easy to write here. I is the identity matrix, and what will be the order of this identity matrix? It will be order 2. Okay. So here it will be 0, identity matrix 1, 0, 0, 1, plus a means it will be 0 minus tan alpha by 2, tan alpha by 2, and 0. So its addition will be equal to what? 1 minus tan alpha by 2, and then tan alpha by 2, and 1. Okay. This is left hand side. Now let's focus on right hand side. This is I minus a times this matrix, cos alpha minus sin alpha, and then sin alpha cos alpha. Okay. So I minus a, I am doing it directly, like this was plus, make it minus. So what it will be here? It is 1 plus tan alpha by 2, and then minus tan alpha by 2, and 1 times cos alpha minus sin alpha, and then sin alpha and cos alpha. Okay. Now multiply these two matrices, and just multiply, and then little calculation will also be required for this. So let's try to complete this because it is very lengthy question. So 1 times cos alpha plus tan alpha by 2 into sine alpha, and then 1 times minus sine alpha, it is multiplying here, okay, and then tan plus tan alpha by 2 into cos alpha. Second row will be minus tan alpha by 2 into cos alpha plus sine alpha, and then the last one minus times minus will be plus sine alpha into tan alpha by 2 and plus cos alpha. Okay. Now you see here there is no space to write all these big expressions, so I am just calculating only one expression, okay, so that you can understand it easily and then you can continue with the question. See, for example, we have cos alpha plus tan alpha by 2 into sine alpha. So here what identity you can use? You see, maybe you can use cos alpha is 1 minus tan square alpha by 2 over 1 plus tan square alpha by 2. That the identity of cos 2a. And sine alpha can be used as 2 tan alpha by 2 over 1 plus tan square alpha by 2. Okay. So just utilize these identities and you will get the answer easily. Now this is 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. And for tan alpha by 2, what you can write? Sine alpha by 2 upon cos alpha by 2. And again, sine alpha can be written as 2 tan alpha by 2 over 1 plus tan square alpha by 2. Okay. So here you see it will be sine upon cos. So I don't think that it is required here. Don't convert it. Okay. So it will be tan alpha by 2. Now what it will be? It will be 1 minus tan square alpha by 2 plus, here it will be 2 tan square alpha by 2 over denominator is same. So 1 plus tan square alpha by 2. Now minus tan square alpha by 2 plus tan square alpha 2 tan square alpha by 2. It will be 1 plus tan square alpha by 2 over 1 plus tan square alpha by 2. It will be 1. So this complete element will be 1. And you can see in the left hand side also it was 1. Okay. So similarly you can write, you can simplify all the elements. Okay. We'll see for this also, so that we can see whether we are getting minus tan alpha by 2 or not. Okay. I'll try to finish it quickly so that you can save your time also. Okay. Now just it is a matter of time only. Let me write it quickly. Why it is not working faster? Okay. So just calculate this. Minus sine alpha plus tan alpha by 2 times cos alpha. So this is minus 2 tan alpha by 2 over 1 plus tan square alpha by 2 plus tan alpha by 2 into 1 minus tan square alpha by 2 upon 1 plus tan square alpha by 2. Okay. Now multiply this tan inside the bracket. What you will get here? You and take the LCM as well. So it will be minus 2 tan alpha by 2 plus tan alpha by 2 minus tan cube alpha by 2. Denominator is same, so I am not writing denominator again and again. It will be minus 2 tan alpha by 2 plus tan alpha by 2 minus tan alpha by 2 minus tan cube alpha by 2. You can see here minus tan alpha by 2 will be common. In bracket you will get 1 plus tan square alpha by 2. And what was the denominator? Denominator was also 1 plus tan square alpha by 2. So both will be cancelled and you will get minus tan alpha by 2. And here also you can see minus tan alpha by 2. Okay. Complete this question. I know it is little lengthy, so complete it, and if you have any problem you can write in the comment. Now next question is very important from R.D. Sharma I have taken. Prove that the product of these two matrices is a null matrix when theta and phi differ by an odd multiple of pi by 2. So first understand this line. Theta and pi differ means their difference, or theta minus phi equal odd multiple. How odd multiple yani? It is pi by 2, 3 pi by 2, 5 pi by 2 like this, or in general you can say 2n plus 1 times pi by 2. Okay, because 2n plus 1 is the general representation for odd number. Now we'll see. Suppose this matrix is A, this matrix is B. So A times B is, I'm just multiplying from here, okay? This first row and first column, multiply them. So it will be cos square theta, cos square phi, plus cos theta, sin theta, cos phi, sin phi. Okay, it is just multiply, okay, nothing else, just numbers are big, it is algebraic expression, trigonometrical expression, so that's what it is looking very lengthy. Now first row second column, so it will be cos square theta, cos phi, sin phi, and then plus cos theta, sin theta, and sin square phi. Okay, now first second row first column, so it will be cos theta, sin theta, cos square phi, plus sin square theta, and then cos phi, sin phi. And the last is cos theta, this will be second row second column, cos theta, sin theta, then times cos phi, sin phi, and then plus sine square theta, sine square phi. Okay, now we need to calculate this. So just check whether we can take something common or not. It will be cos theta, cos phi can be taken common. So cos theta, cos phi can be taken common. Theta, phi I have written before. So in bracket you will get cos theta, cos phi, plus sin theta, sin phi. Okay, something can be taken common here also, I guess. So sin phi is here, sin phi is here. Okay, so sin phi can be taken common, in bracket you will get, and cos theta also. Okay, so cos theta also taken common, cos theta, then cos phi, plus sin theta, sin phi. Now next is here what you can take common. We can take cos phi common and sin theta common. So it will be sin theta, cos phi common. In bracket you will get cos theta, cos phi, plus sin theta, sin phi. Then here what we can take common? We can take sin theta, sin phi common. In bracket you will get cos theta, cos phi, plus sin theta, sin phi. Okay, now it is, see, everywhere you have the same expression, yes? So what is it? It is in the, I'm not writing all the matrix, okay? It is the formula of cos theta minus phi. Now you can see cos theta, when cos theta becomes 0, when theta is, if I say cos alpha is 0, so what you will say? Alpha is pi by 2 or odd multiple of pi by 2, because on vertical line for x-axis and y-axis cos becomes 0. Okay, so theta minus phi will be odd multiple of pi by 2, only then cos theta minus phi will become 0. Okay, and you can use it here, trigonometric equation also. Okay, now next question. This type of question will be very lengthy, but it is very easy. Okay, find the matrix A satisfying the matrix equation. So I am taking this matrix as B, this matrix as C, and this is of course identity matrix. So this is B, A, C equal I. What I am going to do here, pre-multiply with B inverse and post-multiply with C inverse. So here also pre-multiply with B inverse and post-multiply with C inverse. So it's a B, A, and C. Okay. Now B inverse multiply B will be identity. A, C multiply C inverse will be identity here. And it is equal to, I will be removed from here, and B inverse multiply C inverse will be C times B whole inverse, because this is from the property of the inverse matrix. So A is equal to C times B inverse. So what we will do here, just multiply C and B. So this is minus 3, 2, 5, minus 3, and here it is 2, 1, 3, 2. So this is minus 6 plus 6, and then minus 3 plus 4. I'm just multiplying, okay? I'm sure you know how to multiply the matrix. If you have any problem in the matrix multiplication, then you can see another video, okay? Now, here it is 5 multiplied to 10, then multiply 3, so it is minus 9. Then 5 times 5, 5 times 1, 5 minus 6, okay? This is 0, 1, 1 and minus 1, okay? So this is C into B. So it is equal to 0, 1, 1, minus 1 and inverse. Now you can find the inverse by finding, first what you will find? You will find absolute value, that is determinant of A, and it will be minus 0 times minus 1, minus 1 times 1, and it will be equal to minus 1, it will be minus 2. Minus 2 is not equal to 0, it means its inverse will exist, okay? Now after that you will find cofactor of A, cofactor matrix of A. Okay, you can find, I have explained this in the video, and then you can find its transpose, and which will be the adjoint of A. At A I am writing because this BC, it is CB, okay, not exactly A. So adjoint of A will be the transpose of the cofactor, transpose matrix of the cofactor. And then what will be A inverse? A inverse is the 1 over determinant of A times adjoint of A. Like this, you can find the value of this inverse matrix and you can complete the question, okay? I know this these questions are little lengthy, and I finished in this in very quick manner. But if you have any problem in the solution or explanation, then you can write in the comment. I can make another explanation for you. But if you think that such videos will help you to increase your knowledge, please like and subscribe my channel and share with your friends. Thank you.